Hello everyone. Today we will discuss something about electromagnetic and wave. Normally you must have known that what is actually wave looks like. It may be a sine wave, it may be a triangular wave, it may be a square wave. Wave means it's a time varying quantity. So EM wave is altogether a new concept. Before coming to the actual EM wave concept, let us understand in today's class actually what I am going to cover. In the outline I have enlisted those. I will introduce what is actually the wave is. Secondly, I will discuss if there is a wave, the parameters of the wave. Parameters of the wave means what is the frequency, what is the time period, what is the wavelength, etc. Then I will actually introduce, after knowing all these parameters of normal wave, how the EM wave can be related to the normal waves. Then EMF orientation. EM wave is not like a normal wave that we are drawing on a paper and we are trying to analyze the behavior of it. Actually, it is drawn in a 3D orientation. I mean, three-dimensional view we need to see. Okay. So, moving, just a second. Yeah. After enlisting the outlines that what I am going to discuss today, we will understand actually how the wave look like. From childhood, like from class 9th or 8th, you must have drawn a wave on your paper. Like this, if you hold a pen and try to draw a wave picture, it looks like this. You need to draw two coordinates, x-axis and y-axis. There you try to find trace a curve. That may be, okay, you must have the idea how the sine wave looks like, how the cosine wave looks like. It is a simple sine wave. The wave may take any form. It may be sine, it may be cosine. As just I told now, it may be triangular, it may be square. So if a sine wave is the simplest form of wave, that's why I have taken this example. Okay. So sine wave means I will start the curve just from the origin and it will go to a peak point. It will come down again to the origin level, zero level. Again it will go to a negative peak. Again it will go to the zero level. Then positive peak. Likewise, it will go on in a frequency, in a particular frequency manner. So how speed we can draw it, how close curve we can put it, and what is the height that we can take, what is the time we can put. So everything is related to the type of the wave that we are going to learn. Okay, so in any waveform, two things are very important. After drawing the coordinates, x and y axis are to be drawn. Then we are going to draw the curve. In curve, we have to know that at what speed we are going to draw the curve and to what extent we can go from positive peak or negative peak. So that is why if the speed of the curve is more, we are drawing in a speedy manner we are drawing the curve, then the frequency is high. If we are going in a slow manner, the curve, then we tell it the frequency is low. So frequency and wavelength and time period, that are the topics today I will discuss. So these are the symbols I have drawn it. Frequency is to be known while drawing a curve, and wavelength must be known, and time period. Frequency symbol is F, wavelength is lambda, and time period is T. You see, I have demarcated here two positive peak, the distance, and two negative peak, the distance is always same. It is a positive peak, it is a positive peak. It is a negative peak, it is a negative peak. You see, it is totally same. We tell it lambda. Lambda means wavelength, the distance between two peaks, whether it is positive or negative. This is lambda. And of course, the distance is measured by meter, centimeter or millimeter. So, of course, in the next slides, I will make it clear how the dimension is actually given. But the frequency is at what speed we are putting the curve, and the lambda is the distance between the two peaks, maybe positive. Complete cycle, how much time it takes. If we are starting from 0, going to positive peak, coming to 0 again going to negative peak, coming to 0 again. So you see, the time period is starting from the 0 to completion of one cycle. This is called time period T. So three things I just told now. At what speed, what is the distance, and what is the full cycle time. So these are the three things we need to know whenever we are going to draw any curve. Maybe sine, maybe cosine, maybe triangular, maybe square. Okay. Now, if I told that there are three parameters of any curve, then we must know what is the relation between them. If frequency is at what speed the curve is being drawn, and lambda is like distance between two peaks, maybe positive or negative, then how they are related? We must know it. As I have shown, if the speed curve is f and the distance is lambda, then obviously from the figure it was quite evident that f is inversely proportional to lambda. F means frequency proportional to 1 by lambda. Okay. Now, if the proportionality constant is to be removed, it is a proportional means it's a relation between f and lambda. But we need to equalize it. To equalize it, we need to put a proportionality constant. There, I have used the c. So if I remove this proportionality constant and it becomes f is equal to c by lambda. So what is c then? C is a very well-known parameter to all of you. Whoever has read about optics, about any form of signal, he knows that c is free space velocity. Free space velocity means any light signal, if moves in free space, then at what speed it is going to move. So I am correlating light with the EM wave. As we are reading about EM wave, we can correlate it with optical signal, or that is light. So that is at what speed the light moves in free space is called free space velocity. So we can use it in EM wave analysis too. So C is equal to a constant. If it is a constant, then its value is not going to change at all, and its value is 3 into 10 to the power 8 meter per second in SI unit. Okay, so okay, C is constant and F is the number of repetition that someone is going to take, and the lambda is the peak, I mean the distance between the two peaks. So how the units then? Frequency unit is hertz. If it is going to a higher mode, then becomes kilohertz. Kilo means 10 to the power 3. Again, it may be megahertz, that is 10 to the power 6, or it may be gigahertz, that is 10 to the power 9. Okay, so hertz, kilohertz, megahertz, gigahertz in the range of multiplication of 3, like 10 to the power 3, 10 to the power 6, 10 to the power 9. Then wavelength, as we have seen the relation, F is inversely proportional to lambda. That means what? That means whatever range the F will take, the lambda will take the opposite range. How? In a reciprocal manner. Wavelength, the highest in SI unit, we can give the dimension of wavelength in meter, in centimeter, in millimeter, and in micrometer. So I can ask you a question, very simple question. If somebody is representing F in gigahertz, then 10 to the power 9, 10 to the power 9 is F. Then what should be the range of lambda? Lambda should be 10 to the power minus 9. So if the more the frequency will go increased manner, the wavelength will decrease. If we are giving the frequency to be in a gigahertz range, then wavelength must be in micrometer range. 10 to the power 6 or 9, 10 to the power 3, minus 3 or minus 9. Minus 6 or minus 3. So anyhow, the conclusion we can say that frequency and wavelength are related reciprocally. The more the frequency will be, the less the wavelength will be. This is how the fundamental rule or thumb rule we can say to draw any EM wave structure or normal wave structure. Time period also I have discussed that time. Time period, if we see, there also I have not given the T nomenclature from where the origin is started and it completes one cycle. Then the time period is told to be T. So time period unit must be in seconds. That's why I have written in second. It may take minutes or hours, but we never take any waveform to draw minutes or hours. Like we'll start from 0 and we'll wait 1 minute to complete, then we'll come to the negative half cycle. It never happens. So always T is in second format in SI unit. So let me recap. In recapping, I will say I started with the structure of wave. In wave, I gave you 3 dimensions or 3 parameters to be taken carefully consideration. That is frequency, wavelength and time period. Frequency is defined as the number of repetition done in 1 second, that is denoted by F. It may take the unit as hertz, kilohertz, megahertz or gigahertz, and lambda is the reciprocal of frequency, that is it may take the unit of meter, centimeter, millimeter or micrometer. F is inversely proportional to lambda. So whenever f increases, lambda decreases. And time period is the time taken for a wave to complete one complete cycle, starting from 0 and going to 0 level again. Then we can see, after knowing all these things, if I'll ask, then why we're going to draw a wave on the sheet or on the board? Why should we learn about the waveform? There the power of communication system comes. Communication system means if we can communicate from a sender to a receiver in any form, then that is in the form of signal. So if I am talking to you, that means what? I am communicating to you something, that knowledge I have. So I am talking since 10 minutes, I am talking about an information that you need to receive. Then that becomes a signal. So signal is nothing. It is a time varying quantity with some useful information in it. Then if I can say that between you and that means what? I am saying you are listening. Of course, the signal is there. Otherwise, my message is not would not have received by your brain or your eyes or by your ears. So, if we want to communicate my voice to any receiver, then I have to use one form of signal. It may be simple text or audio or video. So it is now total world is connected through the communicating devices only. Communicating devices means somebody has to speak and somebody has to listen. Maybe it is a public gathering, maybe it is one-to-one, maybe it is through computer, maybe it's through phone, maybe it's through satellites, maybe in any form of communicating device. So we have to connect ourselves with the receiver through the transformation of signal only. So I just gave you the information about drawing the curve. Then why the signal is coming? Because right now I am going to explain why the necessity of signal is required to communicating a signal. Means we need to draw a signal, then only in the form of curve, then only you will understand how the message can be converted to curve and it can communicate. That is how the class is all about. EM wave actually you are approaching. EM wave means just before what I drawn is not a EM wave. That is just normal sine wave. But now I am telling that I am going to use EM wave in my further lectures. What is that? Okay. Electromagnetic, EM wave means electromagnetic wave. So just now I told, if I want my voice to be listened by you, if you are sitting in front of me, then it's very easy and simple. I am talking and listening without any device. But let us imagine I am talking here, but somebody else is sitting like 100 kilometers far. Then what can I do? Can I use such a system where no long cable will be there and I'll be talking in microphone and there would be one loudspeaker and you will be listening? It's not possible. It is not possible to take 100 kilometers of cable just to listen my voice. So where the distance is more, but I want to communicate, then what I should do? I should take the help of antenna. Of course, my next lectures will be in those devices only, how the antenna works and all. But for today, you must know, before going to EM wave, that signal is communicated from transmitter to receiver or from a speaker to a listener with the help of antenna only. Where the distance between the transmitter and receiver is more, we have to take the help of antenna. So antenna is a device that will help in communicating the signal in form of EM wave. Okay, so EM wave, it is present in space through an antenna. As simple as the definition is. Definition is just a signal which is originated from antenna. So we need an antenna to understand actually what is an EM wave, that I will explain for the lectures. So E and M, as the name suggests, total wave have focused in two letters, E and M. E means electric wave, M means magnetic wave. Electric wave, everybody knows, is a vector quantity, electrostatic field. So that is the unit is volt. And magnetic wave means H, magnetic field strength, and that unit is ampere turn. So normally signal means everybody has a normal belief, and we can say that strong idea that signal means an electrical signal. One battery would be there, we can switch it on and current will pass through the network, that means that's the electrical signal. But now we are talking something else. We are talking that how our signal will be propagated in space of my voice. So in form of EM wave. So there is no cable, nothing. but there will be electric field and magnetic field. So this is how the electromagnetic wave will work. It is quite interesting to learn by any of the student who is interested in communication reading, that how actually is a miraculous thing. One device is capable of converting my voice into EM wave, and that will propagate in space, and that signal will be caught by another antenna, and that will be again converted to my voice, and they will listen. Isn't it very miraculous? But it has happened by the very great scientists of Hertz, Marconi, like those some scientists. Numerous antennas have been designed to convert signal, I mean video signal in electromagnetic wave. So electromagnetic wave is as interesting as we will see in future. So if this is so, normal wave is very easy to draw, having a frequency f, maintaining a lambda, and maintaining a time period t. As simple as that. But EM wave is bit different, not difficult. It is bit different. How? We need to, before drawing an EM wave, we need to see, understand what actually the characteristic of EM wave. Everything. See, whenever I am meeting one friend also, we need to understand what is his characteristic. If he is capable of making me with me the friendship or not. Like he has what likings, or she has what denies, or she is capable of maintaining the relation or not. So if we are trying to know a new thing, in form of wave again, not an electrical wave, it is an EM wave having strengths involved, electric field and magnetic field, then we need to know the characteristics of it. It is a bit different. How? As I told just before slide, electric field has two fields, electric and magnetic field. Now I will not write those electric and magnetic word. I will just write E and H. Please try to understand. E means electric and H means magnetic. So those fields are perpendicular to each other. Again, it might be going out of your brain. How the fields can be perpendicular to each other? Perpendicular means 90 degree. Two fields are there, they will maintain 90 degree. How? I will explain in the next slide. But it is the first criteria for the EMF to be achieved. If the E and H are not maintaining 90 degree, then you understand this is not a EM wave. We have to work on it. Then they should be perpendicular. Electric field depends upon the permittivity. See, whatever, if I am speaking and you are listening, it is going in space. There are also two constants involved always, because in space or in media or in water or in air, in paper, everywhere there is a media. Signal is transferring means that media is getting disturbed. That media may contain two parameters, that is permittivity and permeability. Electrostatic field or E field is always affected by permittivity of the media. That we represent by epsilon. You can see epsilon is epsilon 0 and epsilon r. Electric field depends upon the permittivity. Okay, that is epsilon. And magnetic field depends upon permeability. As we have two fields in EM wave means two fields E and H. E depends upon permittivity and H depends upon permeability. So E epsilon and mu for electric field and for magnetic field. So epsilon 0 into epsilon r, mu is equal to mu 0 into mu r. Again, two parameters are there in the media, but again they are related by something, constant and variable and all. So it is defined like this, it is defined like this. Then what is this and what is this? We have also given name to it. Epsilon 0 is the absolute permittivity and epsilon r is equal to relative permittivity. Similarly, mu 0 is equal to absolute permeability and mu r is equal to relative permeability. Just the two names are there. Okay, names are, classification is almost same, but we have to just remember what is absolute and what is relative. Absolute means constant, relative means variable. Constant means it must have a constant value. If epsilon 0 is absolute, then its value is 8.854 Newton to the power 12 farad per meter. It is a constant, we need to remember it whole life. Its value is not going to change at all at any circumstances. And as I told, epsilon r is the relative permittivity is variable. For every media it goes on changing. If it is air, then maybe 1. If it is water, then maybe 2. If it is paper, again some other value. So its value go on changing. Similarly, This is absolute permeability. Its value is also. Oh, I'm very sorry. It is Henry per meter. You can check on it. This is Henry per meter. H per m. Please put a note of it. And mu r is the relative permeability. That is again variable. As the r term is there, don't get confused. Zero term is there means it is absolute, it is constant. Value is to be remembered by all of you. And r is there means it is relative. Relative means it is variable. Its value can change. Okay. So these are the characteristics we should know before going to the details of EM wave. Now the fantastic figure is there. You can see just before 4 slides, I drew a wave that was very simple, having only F, only lambda and T. Now you see again there is a waveform, but it looks so colorful and so interesting. Same coordinates are there, but one extra coordinate is there, Z. Because that I drawn on a picture, I mean on a board or on a paper. So two dimensions were there, only X and Y. But here X, Y and Z axis are there. So this is how the EM wave is looking like. It is a very interesting thing that in space we never know we are surrounded by such EM wave always, because we are talking about by phone, where satellites is giving us so many signals as in form of information. All are coming to us in form of this signal only. This is the EM wave. Just before I told that E and H field need to be perpendicular to each other. That means you see the red lines are electric field, and the red lines are magnetic field, and green lines are electric field. You see in each rotation, or these two are maintaining perpendicular nature or not. Can you see the red and green? The 90 degrees there, again red and green, again red and green. Each time you can see the wave is going on repeating in space, maintaining the 90-degree difference. Okay, so the E and H are to be differentiated by 90-degree only if it is a EM wave. So, as we know, any signal has a resistance. Whenever we see a current is passing through any conductor, there also resistance is there. That is why V is equal to IR. That means voltage is given, current is there, but resistance is there to oppose. Without any opposition, nothing can flow. Even if I am talking to you, my signal is going to you, but there are many things in the space, in the environment, which is opposing me. That's why I am speaking louder. So opposition is always there. Here also, if EM is passing in the space, there is also opposition. That is called characteristic impedance. We tell it this. So we can relate the electric field and magnetic field with the help of characteristic impedance as like this. E is equal to ZCH. They will move in the space maintaining the relation like this. And ZC is a new term here I am introducing. It's a resistance offered by the environment. That is called ZC is equal to characteristic impedance. So again, as I told, in the media, two things are there, permittivity and permeability, and opposition is ZC. So obviously, ZC is dependent on these two things only. So ZC we can say mu by epsilon root over. Mu is permeability, epsilon is permittivity. So their root over will give us ZC. So thank you very much for the patient hearing. Till now, you must have understood what is the difference between a 2D wave and a EM wave. 2D wave is always done with X and Y coordinate, and EM wave is always done with the help of X, Y and Z coordinate. Permeability, permittivity are the main criteria for EMF to pass on the space, and characteristic impedance, if not there, then we cannot say the wave is moving without any hindrance. The wave will move, but with the hindrance of ZC, but it is going from transmitter to receiver easily. So for today's class, I hope you have understood how to draw and how actually the EMF moves in free space. Next class, we'll see some other behavior of the EMF. Thank you very much.